Algebra students, this is a question that is going to be on the 4.3, 4.4 quiz and on the Chapter 4 test. Mr. Nyquist, myself, has built a rectangular math castle in the school's field. The structure is 50 feet by 6 feet. So let's just go ahead and draw something. Obviously, this isn't to scale. 50 and 6, that doesn't look very close. But let's just pretend. We have a structure that is 50 feet by 6 feet. We could easily find the area of this structure by taking just 50 times 6, because the area of a rectangle is length times width. So if we do 50 times 6, we could get 300, which is the area of this rectangle. So the problem starts with this setup, but then it says that he wants to increase the area of his structure by 240 feet. Okay, so we're not satisfied with 300 square feet. We want it to be 540 square feet. And we want to increase the area by 500 or by 240 feet by adding the same value x to the original length. So we don't want this to be 50, we want this to be, plus an x here. And adding that same distance to the width. So we're not satisfied with 50 as our length, we want it to be 50 plus x. And the same thing with 6, we want that to be 6 plus x. Set up an equation to solve the problem. This would be a satisfactory equation that we want to solve this problem. That's what I'm looking for. Now, we've learned how to factor, so we have the capability to actually solve this equation and figure out what the x value should be. What we're going to need to do is FOIL this statement, and by FOILing it, we're going to get still 540 on the left. But we already did 50 times 6, that's 300, right? We did it up here. Plus 50x, plus 6x, and plus x squared when we FOIL. 50 times 6, 50 times x, and x times 6, and x times x. I'm going to rearrange this in the conventional order with x squared in front. Those two can be combined to make 56x, and then plus 300 is equal to 540. Now our goal is going to be to solve this equation, and in order to solve an equation like this, we need to factor it, and when we factor, we want this part right here to be equal to 0. So I'm going to subtract 540 on both sides. That will give me 0 is equal to x squared plus 56x minus 240, and that is going to be the equation I need to solve. Now, when we solve this equation, what you're going to do is you're going to list the factors of the last number, which is 240, and find which numbers add to 56. And so we can list all these numbers, 1 and 240, 2 and 120, 3 and 80, so on and so forth, 4 and 60. We could do this for a long time. We're looking for 2 that would add to 56. However, I just found those, 4 and 60. If the 4 is negative and the 60 is positive, then these numbers multiply to negative 240 and add to 56. So we'd have 0 is equal to x minus 4 from this, and x plus 60. And then remember, to solve this, we use the zero product property, which says if you have a times b and it equals 0, then a must be 0 or b must be 0. So what makes the a 0? That would be 4, and what makes the b 0? That would be negative 60. Now, one of these numbers makes a whole lot of sense to add to x, and one of them doesn't make any sense whatsoever to add to x, right? Because that's what, or to be x, to add to the length and to the width. We could take away 60, and that would make, it doesn't make any sense, right? That doesn't make our area 240 bigger. So really what it's going to be is we're going to add 4 to the length and 4 to the width, making our new structure a 54 by 10 structure. That's going to give us the appropriate area that we were looking for. Let me know if you guys have any questions.